Hello, everyone. Welcome and thank you for joining us today. My name is Eric Deach, and I am the Senior Product Manager of our Nitinol Product Management team. Fort Wayne Metals has a long history of wire drawing and providing material solutions to the medical market. My team and I are excited to take a look back in time and share some key milestones along the Nitinol development path, where we expanded our capabilities to grow with the market. On today's agenda, we're going to begin with an overview and team introductions, followed by the start of Nitinol production in the 90s, form expansion in the 2000s, strategic integration in the 2010s, and then look at today's melt expansions and ongoing developments. Sharing some housekeeping for the meeting. Video chat and microphones are disabled. However, we do encourage you to post questions in the Q&A section and use reactions. We will review the questions at the end of the presentation. We're targeting around 30 minutes for the presentation, leaving some time to review the questions and answers. And those questions and submissions are anonymous and not visible to other attendees. So now for the team introductions. Starting at the top row are Nick Renner and Olivia Schuler in Applications Engineering, and Ashley Harrison, our Nitinol Pricing and Project Manager. On the bottom row are our product managers Adam Nix, Paul Leininger, and Chad Springer. Adam Nix is responsible for our actuator and shape set assemblies. Paul Leininger covers intermediate round wire, rolled sheet and strip, as well as straight annealed bar products. Chad Springer is responsible for fine and ultrafine wire, rolled flat, Nitinol DFT, and silk Nitinol wires. This team is available for the purpose of working with our sales representatives and customers to help solve problems and find Nitinol material solutions that will work best in your target applications. Fort Wayne Metals has a long history of wire drawing and development activities. Our roots go back to 1946 when our founder, Ardell Glaze, started a small wire shop in Fort Wayne, Indiana. Ardell Glaze was a research scientist and the father of our current owner, Scott Glaze. Ardell's spirit of innovation combined with the desire to satisfy customer needs continue to guide our actions today. In 1970, Ardell established Fort Wayne Metals on the site of our current main campus and headquarters. This also coincided with Fort Wayne Metals' entry into the medical market, which is where more than 90% of our products are used today. This has grown to more than a dozen facilities in the US and 2 in Ireland, with a combined total of more than 1,600 employees. As we moved into the 1990s, Fort Wayne Metals expanded our capabilities into drawing Nitinol. With our long history of wire drawing experience, we put resources into drawing Nitinol to support customers' changing product needs and requests as they adopted it for its unique superelastic and shape memory properties. The initial process focused on drawing Nitinol from around 80 thousandths down to fine wire sizes around 7/10 of an inch, 7/10 or 307. With this process development, Fort Wayne Metals began delivering Nitinol into the market in the early 90s. The initial work and Nitinol sales preceded ASTM F2063. So there was a lot of learning on how to test, heat treat, and straight anneal the material, contributing to the industry's development in these areas. This process refinement ultimately led to being the first in producing 100% whip-free guide wire supply. And with that, I'll now hand off to Paul Leininger, who will take us into the 2000s.
Thanks, Eric, and hello, everyone. My role today is to take you on a tour of the first decade of the 2000s and the new product form expansions that we were able to launch into the market at that time. As Eric discussed, Fort Wayne Metals first established itself as a trusted medical device partner through providing high quality medical grade wire on a spool. And there were certainly continued investments in that area as we entered the 2000s, but many new product forms were also launched onto the scene at that time, and we'll walk through each of those now. Starting with the round wire area, we did see an expansion in the diameter of material being offered into the market, starting at the high end of the range with a much higher 1/4 inch coil offering that enabled us to process that material further down into the new ultrafine sizes, some that are even smaller than a human hair, up to and including the 5/10,000ths of an inch wire at the lower end of the range. And this wider range of material just further enabled new product development opportunities for our customers in the marketplace. Next up was the DFT wire product. And this product offering really expanded upon the DBS wire that was initially created by our founder, Ardell Glaze. And while the DBS wire was a composite material featuring a combination of stainless and silver, originally intended for better corrosion resistance and fatigue properties, the DFT wire is a tube and core construction, with a typical construction being a nitinol sheath and either a platinum or tantalum core for improved radio opacity. Silver can also be used in a core when conductive properties are needed for your application. And as we take a look at some of the images on the screen for the DFT wire, the image on the far right is a good illustration of the different forms that the DFT wire can take. And then as we look at the cross sections in the middle of the screen, each of those cross sections compare the advancing and higher fill ratios compared to a solid core. And the middle images show a DFT product formed into a coil construction. And you can see how there is improved visibility under fluoroscopy, comparing the core to the 10% and all the way up the ladder to the highest fill percentage available in our standard range at 40%. So those are really useful for products where either sizing or placement and visualization under fluoroscopy is important. For different customer applications that we've seen, typically see this type of material used in embolic coils and also in braided stents. Strands, cables, and cable assemblies are another area that began in the early 2000s. But again, we saw this area really explode and have a wide range of cable applications for our customers, from cables that are as simple as 2 individual filers, as shown on the left of the image, all the way up to and including very complex cable assemblies like the 37 by 37 construct that's shown there that features nearly 1,400 individual filers in that cable assembly. And in terms of applications, we've seen small diameter cable assemblies being used in robotic surgical offerings to control the instrumentation that's featured on those systems. And at the high end of the spectrum, we've seen very large nitinol cable assemblies being used in seismic damping systems in construction of high-rise buildings and other buildings in earthquake-prone areas of the world. In terms of the construction of these products, it can either be single alloy construction or combination alloy construction as well. To give you a sense of scale, in 2024 alone, Fort Wayne Metals delivered more than 20,000 pounds of strands and cable assemblies into the marketplace. Our straight anneal bar is also a new offering that began in the early 2000s. And this is straight anneal bar that features the super elastic properties you're probably somewhat familiar with in terms of nitinol. And in terms of the size range offering here, at the lower end, we can offer 0.1 inch in diameter or 2.54 millimeters, all the way up to and including quarter inch super elastic bar, 6.35 millimeters. Some common surface finishes that we have here are natural forming oxide and our cellulose ground and polished surface options. In terms of medical applications that we see used here, orthopedics is a pretty common application for these types of bars. We see them used widely in compression nail types of implants where the super elastic properties of the nitinol bar allow the affected area of the bone to be loaded into compression, thereby activating Wolff's Law for improved healing. And we also see this type of super elastic bar used for other instrumentation, including drill bits, pins, and reamers. Rolled flat and shaped wire form was really a new and kind of fun product form expansion that took place in the early 2000s. And I say that it was fun because in some ways it's really only limited by the imagination of our customers. On the screen, you see a number of the more common shapes that we sell into the marketplace. But our team is always up for a challenge. So if you have an idea for a shape that would be, a benefit to an application that you're wanting to deliver into the marketplace, please feel free to reach out to us. The team does love a challenge, and chances are we can probably work with you to deliver that shape into the marketplace. One common commercial application we see from this family of products includes the Turk's head wire, which is kind of a rectangular shaped wire that we see used commonly in orthodontic applications for arch wires in a traditional orthodontic application. Rolled strip, again, picks up where our rolled flat wire leaves off in terms of the width available. So our rolled flat wire stops at 080, and our rolled strip begins at greater than 080 all the way up to 1/2 inch in width. And we see this product being used for product applications where production of discrete items is needed and where the efficiency that can be gained by rolling this spooled material or where loading this spooled material onto a high efficiency, high volume stamping operation is beneficial for the production needs of the application. So one of those applications that we see are for brackets for a traditional orthodontic application, the brackets that traditionally hold those arch wires. We're also seeing increased interest in these strips from cardiovascular companies who are interested in using the strip to create smaller diameter tubing for use in structural heart applications. The last product form that I want to introduce you to today is our shape set and assembly area. Again, this product area was introduced early in the 2000s, but saw a major investment made last year to the point where we're now able to offer all nitinol grades and all nitinol product forms through our shape set and assembly area, including round, flat and shaped wire, cable assemblies, and HHS tube type of product. In addition to those product forms, we do have some value-added services that we can offer through our shape set and assembly area, including wire EDM cutting, crimping, and surface conditioning. So all that really just points to our ability to be able to scale up to meet the production demands of whatever application you may be looking to achieve through a shape set and assembly type of application. And with that, that concludes our look at the early 2000s and the new product forms. And I'll pass it to Olivia, who will walk you through the 2010s.
Thanks, Paul. Today I'm going to take you through the 2010s, where we expanded on the form expansions in the 2000s through strategic innovation. One of the main things 4M Metals did in the 2010s was invest in nitinol melting capabilities. 4M Metals recognized the need in the industry for greater nitinol availability and decided that we should invest to ensure the stability of the market. So we built our Advanced Materials Development, or AMD melt facility, to melt nitinol. And we started providing 4M Metals melted nitinol in 2013. All of our standard material meets ASTM F2063 and has been widely used in medical markets. This anticipated increase in demand for nitinol and the need for added capacity has certainly proved to be a reality. In order to support this, 4M Metals has recently further expanded our melting capabilities with the addition of a second VAR melting furnace and a PAM melting furnace. Today, we are supporting more than 75% of our nitinol sales to medical industry from the melt furnaces at the AMD facility in Columbia City. Further developments in the 2010s were driven by customer needs. As customers came to 4M Metals with ideas of products to develop, 4M Metals was able to use our knowledge of processing materials to hone in on the requirements. DPS wire was engineered to have higher plateaus for customers wanting increased stiffness in nitinol's superelastic region, from strains of 1.5 to about 6%. These increased plateaus can be seen in the graph, which compares DPS wire to USN and superelastic nitinol wire. DPS wire also has further resistance to bending after an initial bend. This makes it useful in applications such as guide wires. Similarly, for applications in nitinol's elastic region, where strains are less than about 1.5%, 4M Metals developed USN wire, which has a high modulus and is good for low strain applications where column stiffness is the priority. The graph shows that USN has a higher modulus than both DPS and superelastic nitinol wire. USN wire is commonly used for guide wire applications because of its increased stiffness during initial bending. Both USN and DPS wire are available in diameters of 009 to 30 thou inches. Another product that was developed to fulfill a customer need was silk nitinol wire. Silk wire is the smoothest oxide-free nitinol and has no visible oxide. In the graph, you can see how the roughness of silk nitinol compares to the oxide-free surface finishes that 4M Metals offers. We've received feedback that it's really good for braiding applications because the smooth surface reduces snagging in the braiding process. Actuators were another area developed as a response to needs seen in the market. To support these needs, 4M Metals created a team dedicated to the development and support of nitinol actuator wire. Nitinol actuators utilize nitinol's phase transformation to perform work. To accomplish this, we select a material with elevated Inga AS, resulting in activation temperatures up to 90 degrees C. The material is in the martensitic phase at room temperature, and then when exposed to a heat source, such as a heating element or current, the wire will heat up and transition to the austenitic phase, thereby contracting and doing work. When the heat source is removed, the wire will return to its martensitic phase and is ready to be elongated by a return force, such as a bispring. This process can be seen in the graphic and can be repeated for millions of cycles. 4M Metals has a proprietary training process to create fully trained actuator wire that actuates and resets at the same temperature cycle after cycle, has no noticeable residual elongation after many cycles, and has decreased reset time after being heated for actuation. And now I'll pass it on to Nick to talk about how we expanded our melt capabilities and what new products we have on the horizon.
Thank you, Olivia. The 2020s, 4M Metals continues to innovate, featuring many new products as well as an improvement and expansion of our melting capabilities. Starting with our large diameter bar, to delineate this from the superelastic bar that Paul mentioned, this bar would be received in the fully annealed condition and 1/2 inch to 2 inches, serving as an input into larger discrete part manufacturing and machining, as well as an input into the tubing industry. Our Altus nitinol is Fortin Metals Gen 2 offering, validated in 2024, featuring less than 20 micron and less than 1.2% area fraction, giving the wire better microcleanliness and increased fatigue performance. Through testing, benchtop RBF or rotating beam fatigue testing, we have seen equal to or better than results compared to other Gen 2 offerings. Currently in 2025, we're focusing on building our inventory to support the wire and bar markets. And you can see in the image below the cross section of our Altus Nitinol compared to our standard, the inclusion size is much smaller. Prime project or proficient ingot material evaluation was a collaboration of 5 trusted Nitinol experts across the supply chain from melting to tube drawing to device manufacturing to validate and establish Fortin Metals as a tubing supplier, featuring both our standard and our Gen 2 Nitinol, creating a robust supply chain and giving another offering to that industry. Moving more to a product offering, our linear elastic, similar to DPS and USN, through processing, we're able to create a linear elastic nitinol featuring a close to 1-to-1 stress strain ratio, giving the wire increased strength while maintaining good superelastic recovery, ideal for applications that require increased pushability or need more stiffness. In the graph below, you can see it kind of splits the middle between a standard superelastic nitinol and a stainless steel. Our nitinobium yttrium is a combination of processing and alloying, creating an increased plateau strength, about 50 to 100% when compared to a standard binary. One of the byproducts of the addition of the niobium and the yttrium is reduced temperature sensitivity. We've seen this material behave superelastic in cryogenic conditions or temperatures. So if you need to downsize your device while maintaining strength, switching to this alloy may be an option. Or if you have an application with a harsh, uncontrollable environment, this could be an option as well to maintain superelastic properties. Custom alloys. So Fortin Metals does have a dedicated research and development team with 2 furnaces at their disposal for quick turn alloy development. So they can go from ingot of a custom ingot to wire form in a matter of weeks rather than months. If a selected custom alloy does show favorable results, we do have the scalability to bring that into a more production scale with our advanced materials development facility that Olivia had mentioned. So what's coming? The and beyond. So the next couple of slides are going to highlight products that are in or have launched from our new product introduction process. This is a staged process to take idea to commercially launched product. Highlighting the 35 NLT DFD NiTi first. This is a cobalt nickel chrome sheath with a nitinol core composite wire. Intended to be taper ground, so the 35N sheath will be taper ground, exposing a nitinol core, giving the wire proximal stiffness with distal flexibility, eliminating additional process steps and failure modes for our customers. This is currently in the NPI process with validation activity ongoing. Our helical Turk's Head nitinol has a square, twisted cross section. This unique geometry reduces the overall contact area by about 60% when compared to a round wire of equivalent diameter. This gives it lower friction and increased tactility again compared to a round wire, with excellent 1-to-1 torque transmission for better navigation to the vasculature. This was launched and is ready for certified production. Paul touched on our DFT product. This is a combination of our flat process and our DFT process, essentially creating a wider surface area of the platinum, increasing radio opacity when compared to a round wire of equivalent diameter. So if a customer needs to increase radio opacity and they're already using, say, a 40% filled platinum, they could potentially switch to this for more radio opacity. Or if you're already using a flat wire in a device and want intrinsic radio opacity without the need for radio opaque markers, this could be an option as well. This is launched as and ready for certified production. Our nitinol sheet, Paul kind of touched on the graduation from flat wire to strip. This is kind of that next step on from strip, where it's just a larger geometry with thicknesses ranging from 3 thou up to just under a 1/4 inch. The thickness does drive the width, so if you have an ideal thickness in mind, reach out to us and we can get back on what width we can provide. This, similarly to applications that Paul mentioned, are good for stamping and laser cutting discrete super elastic parts ready to be assembled into another device. This is currently in our NPI process with development ongoing. And then finally, groove nitinol wire. This has a working channel that runs across the surface. It will be delivered in the super elastic condition. And this also is launched and ready for certified production. And with that, I'll hand it back to Eric for closing.
Thank you, Nick. From the formation of Fort Wayne Metals and throughout the growth of our nitinol production, we strive to find material solutions that will enable our customers to develop and introduce life-saving devices. We're committed to pushing the boundaries of what this alloy can do to support our customers' most challenging demands. From melt through ultrafine wire and all the product forms in between, we have a nitinol solution for you. We could have talked about a half an hour or more for each product, but really just want to share the range of capabilities we have today, as we do so much more than just provide wire on a spool. Let us know if you'd like to have more information. We'd be happy to conduct a review or provide a technical presentation to your team and provide more details in your specific areas of interest. So this is the end of the presentation portion. We did allot some time here to take a few questions. So if you have a question, haven't put it in yet, please drop that in the Q&A section, and we'll take a look at those. And I'll have Adam Nix join me and to take a look at some of the questions that may have come in already.
Yeah, thanks, Eric. We did have quite a few questions come in. Like Eric mentioned earlier, I'm going to kind of generalize them. I'm intentionally not going to include a couple questions based on being pretty customer or person specific. So just some of the questions that I think will help everybody on the call. Someone asked if you can shape set DFT material. And yes, we can shape set DFT. And yes, you can shape set DFT as well. Since the majority of the cross section is still nitinol, it's just 10 to 40% fill of another material like a platinum. We can still utilize nitinol's ability to be shape set. So the image shown in Paul's presentation was of a single wire coil, but a really large or major use case of DFT is in a braided stent application where you need better visibility under X-ray. So these stents can be shape sets similar to their monofilament wire counterparts. There will likely be a little bit of development that needs to be done, to determine possibly changing the time and temperature slightly. But for the most part, the same principles apply, and you can shape set nitinol DFT. Another product combination question that we had was, can we make DFT and silk nitinol? And yes, we can. So similar to that braiding application. So if you're looking for improved braiding performance, so less snags, but also getting visibility under X-ray, silk nitinol DFT could be a great option to achieve both of those. There's a question about the linear elastic product that we shared. What are the min and max sizes for linear elastic? And the min and max sizes for linear elastic are 003 or 3/1000 of an inch to 25/1000 of an inch. Someone asked, where are we actually melting our Fort Wayne melted nitinol and how much are we melting? So melting occurs, like was mentioned, in a Fort Wayne Metals facility about 30 minutes from where we sit in Columbia City, Indiana. With capacity increases in regards to how much we melt, we believe that by the end of this year, we'll be exceeding 800,000 pounds of nitinol. And then a lot of projects that are currently ongoing that will likely hit in 2026 should push that capacity over 1 million pounds of nitinol a year. There was a question about where do we normally see nitinol strand and cable applications? There's quite a few different use cases, both in medical and non-medical, but a great medical application for this would be when you need to pass the nitinol across a tighter bend radius than a typical wire will allow. So think of like maybe a suture passer or something like that. In those type of applications, you can go to a strand or maybe even multiple strands together to make a cable. and be able to achieve a much tighter bend radius. So like a 1x3 or a 1x7 would be a really good place to start if you're looking for a tighter bend radius. Let me go ahead and scan the questions here.
Adam, while you're looking at that, I saw another question come in for nitrile-niobium. We do offer nitrile-niobium yttrium. It's a quaternary alloy. This alloy with processing, we are achieving nearly double the plateau strength, so a much stronger wire, and with super elastic function in the lower temperature ranges as well. So we'd be absolutely happy. We do have this on our website, but we'll happy to reach out and share some more information with that alloy as well.
Yeah, that's another kind of ties into one we just received as well about other ternary or quaternary alloys. So obviously you just mentioned nitrile-niobium yttrium, existing, we'll call them quote unquote legacy products of nitrile number 2 and nitrile number 3, where we intentionally duped in some cobalt or chromium, achieve the same principle. But for the most, we'll call it bang for your buck, the biggest increase that you can get, nitrile-niobium yttrium is our current best quaternary alloy offering.
Adam, I saw another question related to is the silk surface finish only available for nitinol? Silk nitinol is a nitinol product. It is processed with an oxide-free surface, and with that the smoothest surface available. We certainly can reach out to our core segment, who for their best surfaces available in other alloys if you're looking for something like that. So we could certainly look into those, but silk nitinol is specifically a nitinol product.
There's a question about the timing of nitinol sheet. So nitinol sheet is a process that we're developing right now. That being said, if you have an application or you have an immediate need for nitinol sheet and we'd like to trial some Foreign Metals nitinol sheet, please reach out and we can get you some material on a limited cert basis. So we can at least get those conversations started. And then from there, we can determine what the timing looks like to be able to provide full certifications.
There's another question related to any plans for Ireland or Europe for melding our nitinol in larger products. Today, we have no plans for that. We are constantly evaluating, I think, as we did when we put manufacturing where we have stainless and nitinol in Europe today. But we have no current plans for that.
That's all I'm seeing. Eric, do you see any others that we didn't catch?
Sorry, I don't think so, Adam. But I do. We'll double check these and reach out to try to make sure we answer any questions that anybody submitted. And I think that's it on the questions for this part.
Yeah, like Eric mentioned, if there's anything that we maybe missed, please let us know, or we'll get a copy of all these questions. So if there's anything we missed, we'll be reaching out individually for some more information.
Great. So with that, I would like to just take a minute to remind you that we do have regional sales representatives located around the world to serve you. Please reach out to them and they'll put you in contact with our team to support you directly. And with that, in closing, thank you for joining. We appreciate your time, and we're looking forward to our continued partnership in supporting life-saving devices. Hope everyone has a great day. Thank you.